All right, let's dive into a piece of your network security that's absolutely critical, but, often gets overlooked. The switch. It's the foundation of literally everything, but so many times it's just left vulnerable. So today, we're going to break down layer by layer exactly how to lock it down tight.
I love this quote because it just hits the nail on the head. Your switch really is the central nervous system of your local network. If an attacker gets control of it, they can see everything, they can intercept traffic, they can disrupt your entire operation. The stakes? They couldn't be higher.
So where do we even begin? Well, we start at the most fundamental level, the physical ports themselves. This is ground zero, our first line of defense, and it's all about controlling who can plug into your network and what happens the second they do.
This first step is almost laughably simple, but honestly, it's one of the most effective things you can do. Every single open, unused port is just an open door, an invitation for someone to walk right in. So the very first thing you do is go through and use the shutdown command on every single port you're not actively using. Right away, you've massively reduced your attack surface. Now, for the ports that you are using, we have to defend them. And this is a classic attack. With a MAC flood, an attacker just spams the switch's brain, its MAC address table, with garbage. When that table gets full, the switch basically has a panic attack. It forgets where every device lives, and it stops being a smart switch and reverts to being a dumb hub, just blasting every single piece of data out of every single port. It's a performance nightmare and a gigantic security hole. So how do we stop that kind of chaos? Simple. We hire a bouncer for each port. And that's pretty much what port security is. It's like having a security guard at the door of each port, checking IDs and making sure only authorized devices get in. It puts a hard limit on who's allowed to talk, stopping an attacker dead in their tracks.
And turning it on is a pretty simple two-step process. But, and this is super important, you can't just flip the main switch. You first have to tell the port what its job is. You have to set it to access mode. That tells the switch, hey, this port is for a regular end device, like a computer or a printer. Then, and only then, can you apply the main switch port security command.
Okay, so our bouncer's on duty, but how do they know who's on the guest list? Well, we've got 3 ways to do it. We could go static and manually type in every single allowed MAC address, super secure, but a huge pain to manage. We could let the switch learn them dynamically, but then it forgets everything when it reboots. Or we can use the sticky method, which is really the best of both worlds. The switch learns the address dynamically the first time it sees a device, and then it automatically saves, or sticks, that address right into the running configuration.
So what happens when some unauthorized device tries to crash the party? You get to decide the punishment. Shutdown is the default, and it's the most secure. It just kills the port completely until an admin manually brings it back up. Restrict is a little nicer. It drops the bad guy's traffic and sends you an alert, but it lets the legitimate user keep working. And then there's Protect, which is, well, it's kind of the silent treatment. It drops the traffic, but doesn't even tell you. For most people, the real choice is between the iron fist of Shutdown and the more flexible approach of Restrict. Okay, so we've got the physical ports locked down. That's a huge win. But modern networks are all sliced up into virtual LANs, or VLANs, right? So our next layer of defense is all about making sure those virtual walls are solid and stopping attackers from hopping from one VLAN to another. And this, right here, is the threat. An attacker is sitting on, let's say, the guest VLAN, and they manage to trick the network into letting them see traffic on the super secure server VLAN. How do they do it? Often, they exploit something called DTP, the Dynamic Trunking Protocol. They basically fool the switch into thinking their laptop is another switch, which creates an unauthorized trunk link, giving them a backdoor to everywhere. The defense against this is a 3-pronged attack. First, any port that a user plugs into, you hardcode it as an access port, period. Don't let it try to negotiate anything. Second, even on your real trunk ports, you turn off DTP negotiation. And finally, a really important one, change the native VLAN. Never, ever use the default VLAN 1 for anything important. It's the first place any attacker is going to look. All right, our next layer of security gets right into the world of identity. How do we stop attackers from impersonating legitimate devices on our network? Pretending to be the router in a classic man-in-the-middle attack? These attacks often start with DHCP. An attacker can launch a starvation attack, where they just ask for all the available IP addresses until there are none left, which is basically a denial of service. Or, and this is way more dangerous, they can run a spoofing attack. They set up their own fake DHCP server and start handing out bad network info, telling your computer to send all of its traffic through the attacker's machine first. So the foundation for our defense here is something called DHCP snooping. I want you to think of it as a firewall, but one that is hyper-focused only on DHCP messages. It works by making a really simple but powerful distinction. The ports connected to your real DHCP server, those are trusted. Every other port where a user might plug in, by default, those are all untrusted. Now, as DHCP snooping sits there watching all the legitimate IP addresses get handed out, it's quietly building this incredible database in the background. We call it the binding table. This table becomes our absolute source of truth. It creates a reliable, trusted map of exactly which MAC address has which IP address on which physical port. And this table is the key to everything that comes next. So now we've got this perfect, trusted database, this source of truth. The big question is, how can we leverage it to stop one of the oldest and, frankly, most effective attacks at this layer, ARP poisoning? The answer is a feature with a great acronym, DAI, or Dynamic ARP Inspection. Here's the analogy. If DHCP snooping is the meticulous record keeper building that trusted database, DAI is the detective. It intercepts every single ARP message on all those untrusted ports and checks it against the binding table. If the information in the ARP message doesn't perfectly match our source of truth, DAI knows it's a lie and just drops it on the spot. Attack over. Okay, for our final layer, we're going to protect the very architecture, the very blueprint of the network itself. We need to secure the spanning tree protocol, or STP. That's the protocol that works behind the scenes to prevent catastrophic network loops. On all of our user-facing ports, we enable a powerful duo. First step is port fast. This is really for a better user experience. It lets a port become active immediately, so users don't have to wait 30 seconds for spanning tree to do its thing. But running port fast alone is risky. That's why we always pair it with its security partner, BPDU Guard. This feature basically listens on those port fast ports. If it ever hears a spanning tree message coming from what should be a simple PC, it knows something is very wrong, like another switch was plugged in, and it instantly shuts that port down to protect the network. So let's just pull it all together. What we've built here is a really powerful, layered defense. Think about it. We started with basic physical hygiene by shutting down unused ports. Then we added MAC address control with port security. We hardened our virtual boundaries by killing DTP. And finally, we started validating device identity using that powerful 1-2 punch of DHCP snooping and dynamic ARP inspection. See how each layer builds on the last? That's the whole idea. And that brings us to one final thought. We've spent this entire time basing our security on a pretty simple choice. A port is either trusted or it's untrusted. That binary classification is the foundation for so much of what we just talked about. But as our networks get more and more complex, more dynamic, we have to ask ourselves, is that simple black or white classification going to be enough for the future? It's definitely something to think about.